We've learned methods for describing the central tendency of our data and the spread of our data. Let's look at ways to describe the shape of our data. Remember this chart of Apple weights? These weights are what we call normal distributed, also known as the Gaussian distribution. The normal distribution shows up a lot. Heights, blood pressure, and IQ all follow a normal distribution like our apples did. The key features are that it is symmetrical around the mean. The mean, median, and mode are all the same, and our normal distribution also has tails on both sides, which approach but never touch the x-axis. Finally, by applying the empirical rule to any normal distribution, we can determine the proportion of values that fall into certain ranges of the mean. 68% of our points fall within 1 standard deviation, 95% within 2, and 99.7% within 3. We're going to be seeing a lot of the normal distribution. This is because a lot of statistical tests require that our data is normally distributed. This may sound like a big limitation, but it really isn't. We'll explore why in Chapter 3 when we discuss the central limit theorem. Data also comes in distributions that are not normal. It can be bimodal, parabolic, flat, asymmetric, or just about anything. Asymmetric data distributions are common and are often described in terms of skewness. Skewness describes where the data is clumped and where the outliers tend to occur at. With negatively skewed distributions, most of the outliers tend to be on the left of the mean, pointing in the negative direction, while most of the data tends to be clumped to the right of the mean. With positively skewed distributions, the outliers tend to be on the right of the mean, with data clumped on the left. Kurtosis is another description, which focuses on the weight in the tails and around the mean. More or less normal distributions are mesokurtic. In platykurtic, the weight of the distribution is spread around the mean, with very little distribution in the tails. And leptokurtic distributions are more peaked, with very fat tails, and therefore a larger number of outliers as well. While the normal distribution is quite normal, non-normal distributions are also common. In finance, the distribution of asset returns are normally not normal. The S&P 500, for example, tends to be leptokurtic. Real estate, bonds, and commodities and other investments, which rarely swing, tend to be platykurtic.